So page 4, question 5. So first, with this kind of question, normally I need to draw a diagram. You guys see how I operate now. I always draw a diagram first, then I can analyze the force, and then I can write the equation, right? So you guys need to do the same. So say a car mass 1,500 kg, 250 kg is towing another car mass of 500 kg. So I draw this situation. This is a car, and then there's another thing over here. It's going to tow it. So the car got a mass of 1,250 kg, and then the other one, the trailer, has a mass. I'll say this is mass 2. Okay, now I'm not going to get it wrong. I know exactly which one is which one because this is towing, and then it's probably going to the right. Okay. All right. So the car is accelerating. Okay, accelerating at 0.6 meter per second squared. Yeah, a lot of times I find people asking a question, and I draw the graph, then they understand straight away. Okay, assume friction against the motion of the car can be ignored. Okay, we're ignoring friction. No friction, but just these two forces making going forward. Okay, draw a diagram, show all the forces acting on the car, which is being towed. Okay, so we are talking about this car over here, right? So let's have a look. What are the forces acting on this car? I start drawing by the center of mass, right? So first, what are some forces must exist? Yeah, we must have gravity. So we must have gravity going down, and then I label it gravity. And if we have gravity, we must have a support force or reaction force, right? Okay, I'm going to say this reaction force. And these two, I draw exactly same length because these two forces, I know they're going to be balanced. It's not going to move up and down. Okay. All right, what is the next force you have? Yeah, the string is tolling it. If it's tolling it, what kind of force exists inside the string? Yeah, that's the tension force going this way. Is there a friction force going backwards? No, they tell us friction force is ignored, right? So there's no such force. Okay, so now, say question B, write a vector equation to calculate the tension force. So this one says a vector equation calculates the tension force. Actually, we don't even need a vector equation. We just need an equation to calculate it. B. How big is this tension force? Well, this car is accelerating, right? What is the force making it accelerate? It's just the tension force. Because the tension force is pulling it that way, right? So the tension force is the net force, which is going to make it accelerate. Does it make sense? Because vertical direction forces are cancelled, right? Okay, and then we put it in there. Okay, that's 850 times 0.6. Put that in my calculator. 510 Newton. Okay, so that is going to be the tension force. Straight away, just like that. Okay, all right. And then question C, draw a diagram, show the forces acting on the car which is towing. So now we're talking about this car, right? Okay, so let's have a look. What are the forces can act on this car? Again, first we must have gravity, which is going down. I'll draw a little bit bigger than this one because this mass is bigger. Okay, gravity going down, then we got support force going up. The reaction force is going to be same size as this one. Okay, and what are the other forces acting on this car? Yeah, very good. There should be a tension going backwards. Because if this car is pulling this thing forward, and this car will be dragging this car backwards, right? And how big would this tension force be? Yeah, the tension force is equal to that tension. Because we've tried it with my clothes, right? If you pull my clothes this way and the other person pulling clothes that way, the tension force always come to paired and they're equal to each other. Okay, so that's my tension force. And then obviously we need to have a big force going forward, which is called the, I guess we call it the thrust force. But the thrust force is actually just a friction force from the car wheel making it go forward, right? So let's call it thrust force. Okay, and then it says these are the forces acting. Write a vector equation to calculate the forward force of the car's engine. The so-called forward force of the car's engine is this thrust force, right? Yeah, but it's actually not coming from the engine. It's actually the friction force from the wheel, right? You guys have learned, we talked about this yesterday. It's the friction force from the wheel make it go forward, yeah. But then what we call it that, it doesn't matter what we call it, so this is the force we want to calculate. Okay, so now again, so net force are right over here. Net force is gonna make the mass accelerate, right? And if we're looking at this object, I don't need to consider this object anymore. I'm purely looking at this object, right? So that is gonna be mass 1 times the acceleration. Where does this net force come from? What does the force make this net force? It's a thrust force minus the tension force, yes. So let's say F thrust, I'll say THRUST, take away the tension force. That gives me the net force. And that net force makes the object accelerate. Does it make sense? Okay, so first thing what we do is, I sometimes just ignore here. I just go straight, this thing minus this thing equals to MA. That makes me like easier. I know not making mistake. Because sometimes you might calculate net force. After you calculate it, you're like, oh, do I add tension or do I minus tension? And it makes it more confusing for you. Does that make sense? Okay, so I go this. MA, that is mass 1,250 times 0.6. And then put that in the calculator. 750 Newton. And then that's my net force. And that will equal to the thrust force minus tension force, which equal to this one, 510. So now I will get my thrust force will equal 750 move to that side, actually add 510. That will give me 1,260. Does this make sense? Okay, this step over here, you need to take your time. It's the mass acceleration get you the net force. The net force is caused the bigger thrust force minus the tension force. So this question, you need to divide this thing by 2 sections over here. Analyze this section first, and then analyze this side. Does it make sense? Okay, so there is one more way to analyze this question. There is an easy way. Another way of analyzing this question is this. If you want to calculate the thrust force, right, you look at the thing as a total. As the whole system is accelerating forward, right? And what is the force making the whole thing going forward? It's just this thrust force. There's nothing else. So in fact, the thrust force is the net force of the system, which equals ma. So this mass, I have to use mass total. If you got the total mass, 1,250 plus 850 times the acceleration 0.6. Okay, put this in the calculator. See what number you get.
Wait, is this date or how much is this?
Okay?
Wait, never mind.
Yeah, what is it?
Same thing.
Same thing, 160 Newton, right? So this, yeah, the thrust force, because now these two forces are the internal force, you can ignore it. If you look at the whole thing, what are the forces acting from the outside? It's just the thrust force making it going forward. Because the vertical forces are cancelled. And this is an internal force, it doesn't matter. Say, if you are sitting in a car, right? Imagine this, you and your friend are sitting in a car, for some reason you started fighting, and then you pushed her. Does that make any difference in terms of the car moving forward? No, it doesn't, because that's the internal force. It's happening inside the car. If you push her, she's going backward, but you're going forward. You push her backwards, she's giving you a force going forward. That's actually all cancel out. It's all internal. If you look at the whole thing from the big picture, it's the thrust force making this car going forward. That's why there's this other method over here. Does it make sense? Okay, see, you can have a little bit of time to have a think about it, okay? All right, awesome.